Okay, this question is about potassium. Humphrey Davy was a professor of chemistry and he did some work in 1807 on electrolysis experiment, the key word there being electrolysis. Davy first tried to electrolyse a solid potassium salt to produce potassium, another key word, solid. Explain why electrolysis didn't work. Well, what you need to do is you need to remember what the definition for electrolysis is. Electrolysis is the splitting of an ionic compound using electricity. However, this compound must be molten or in solution. And why is that? So that ions can move. So if you look back at the question, you can see that it's a solid potassium salt, and the answer to the question is basically that the ions were not able to move as he was using a solid salt. Guarantee the 2 marks, you need to start specifying something from here. The idea of that the ions need to be able to move, so I think you should probably put something down about things being molten or the solution being used rather than the solid to guarantee those 2 marks. Right, the next bit of the question, you've got the idea. Here's the scientist's name. Humphrey Davy was the first person to produce potassium. His new idea was accepted very quickly. Why was this? Well, it all comes down to this little bit here. A professor of chemistry. And Humphrey Davy was a respected chemist. So what he said, people believed. Also, he had proof. Look at this. This is what I've done. It has worked. And other scientists were able to follow what his work, so it was repeated by other scientists and they got the same results. Therefore, it was quickly accepted. Okay, so we've got potassium chloride dissolved in water. Potassium chloride, KCl, dissolved in water, H2O. So actually, what we haven't got this and we haven't got that in this, the electrolyte. What we actually have got, we've got potassium ions, chloride ions, hydrogen ions, and hydroxide ions. If this is the positive electrode, this is the negative electrode. So what's going to be attracted where? Well, that's a positive, that's a negative, that's a positive, that's a negative. So the chlorine, Cl minus, is attracted towards the positive electrode. H plus is attracted towards the negative electrode. And the question is going to start asking, well, why isn't that attracted to the negative electrode? And what you need to do is look on the reactivity series, which is on the back of the periodic table, and you'll see that potassium is here and hydrogen is down here. Therefore, potassium is more reactive than hydrogen. So potassium ion stays in solution and the hydrogen ion is attracted to the negative electrode and therefore producing hydrogen gas. You've got to remember the more reactive element or the more reactive ion is going to stay in solution. If you want to take that a little bit further, the potassium ions are less easily reduced. Hydrogen is more easily reduced, and reduction is addition of an electron, again an electron, and therefore that's how you get hydrogen gas produced. This all relates to this question here. Name the gas produced at the negative electrode. So having a little think, look at our diagram. There's our negative electrode, so hydrogen gas. Is produced at the negative electrode. Potassium is more reactive than hydrogen Therefore, the potassium ions stay in solution. And just to make sure, hydrogen ions are positive, these are attracted to the negative electrode. This question, it's important that you realise that it's trying to electrise molten potassium chloride. This is not involving water. Okay, therefore potassium metal was produced at the negative electrode. Well, we already know that K plus is going to be attracted to the negative electrode. So what actually happens when it gets there, it says that potassium metal is produced. So we've got K plus becomes K. So how is that happening? Well, it must gain an electron. So potassium gains one electron to become potassium atom. This is the potassium ion. It gains one electron to become the potassium atom. To balance the equation, we've got two chlorines here, therefore we're going to need two chloride ions. We've got a charge here of -2. We've got no charge here, so we're going to have two electrons. And the next little bit, complete the diagram to show the electron structure of the chloride ion. You use the periodic table. Right. Find chlorine, you see that it's got an atomic proton number of 17. So it's got 17 protons. Therefore, in its atom, it would have 17 electrons. But it's a chloride ion. That means it's gained an extra electron. So it's actually got 18 electrons. So we start off 2 in the first shell, 8 in the shell afterwards. It's easy, if you pair them up, that's easy to count to 8, and you don't make any mistakes. And then if you do your next 8, there you go. Remember, the first shell can hold a maximum of 2 electrons, the second shell can hold a maximum of 8, the third shell can also hold a maximum of 8. 2 plus 8 is 10. 10 plus 8 is 18, 18 electrons in its ion.